Okay, so this is problem 21 from chapter 4. In this section, we're talking about special cases of the node voltage method. And the special case that they wanted to point out is a case where the independent voltage source is connected to two nodes. In that case, then we know what the voltage is going to be at that node, and that's going to be the voltage source. Meaning, if you stick your DMM from here to here, what would you see? You would see 20 volts, which means we know what that node, the value of that node is. And that's the special case that they're talking about here. So, now that we know that what we're trying to do, we have a circuit where we have 2K here, 5K here, 5K here, 30K here, and 1K here, and we're trying to find the current between these two nodes. And we're supposed to use the node voltage method to do that. So we know what this node is. That's the special case, and that's 20 volts. So the nodes that we don't know is right here. So I'm going to call that VA, and I don't know what that is either, VB. It's going to be 20 volts split into something, but I don't know how it's split yet. So I need to find that because I'm looking for ultimately for I naught, and I naught is going to be VA minus VB over 5K. So in order to find the I naught, I need to find VA and VB. So let's get started with node voltage. Remember, the node voltage method is basically an application of Kirchhoff's current law. It says that the sum of all the currents away from the node will be 0. So starting at this node, we're going to go VA minus 20 over 2K. That's that node, right? Voltage, difference in the voltage divided by the resistance is the current. Plus VA minus VB over 5K. Again, that's another current term. I've got V, voltage over current, which gives me voltage over resistance, which gives me current. And then the last branch current here is going to be VA over 30K. All that's got to be equal to 0. So now I'm going to collect all of my coefficients because I'm not really going to solve this. I'm going to use my calculator. So I'm going to go VA, collect all of the coefficients. Got 1 over 2K plus 1 over 5K plus 1 over 30K, and then VB, and my coefficient for VB is -1 plus VB, 1 over 5K, and then put this constant over on the other side. That's all got to equal 20 over 2K. Again, I let my calculator do all the hard work. So that is equation number 1 that I need for my simultaneous equation solver. Next node we're going to do is at VB. We've got VB minus 20 over 5K plus VB minus VA over 5K plus VB over 1K. That all has to equal 0. Now collect the coefficients. VA has coefficients of -1 over 5K plus VB has coefficients of 1 over 5K plus 1 over 5K plus 1 over 1K, and put the constant on the other side over 20 over 5K. Put that into your simultaneous equation solver, and you should come up with VA is equal to 15 volts, and VB is equal to 5 volts. So put that into VA minus VB, so that's going to be 15 minus 5 over 5K, and you should come up with I naught is equal to 2 milliamps. And that is the answer to problem 21. Remember to share the video if it helped you. Thanks.